All right, so on this question, all we're looking for is absolute extrema. We're not looking for max and min, relative max, relative min, and intervals of increase. Just what is the biggest number and what is the smallest number. And what we're given here is a closed interval. And we're also given a continuous polynomial. So if we know that's continuous, we know that's closed, we can use the extreme value theorem and find a max and a min. We know 100% there are one. So here's how you do that. The first thing you're going to do is find your critical points. So if we take our derivative, we would get 60x to the fifth plus 5 times 24, which is 120, x to the fourth plus 60x cubed. And then we set it equal to 0 and find our critical numbers. So 0, 60x, and then the smallest is cubed. So we end up with x squared plus 2x plus 1. And so that would then give us x plus 1 squared equals 0. And so we have critical numbers at 0 and at 2. And so what we're going to do now is plug in the critical numbers and endpoints. So I'm going to show you this graphically why we do this. So if you take out your calculator, plug your function in, and then we have a closed interval. So you're going to go to your window and enter that interval in. So our x min is negative 0.5, and our x max is 2, and then we're going to hit zoom 0. And so what our graph is doing is it's coming down and then going all the way back up. So that is our highest point. So if we're looking for absolute max, then our critical points and our two numbers here, our endpoints, are where those max and mins will occur. So if you want to see what this really looks like, we could sit here and change it. So if I change my window and I change my y max to 10, you can see the graph does that. So it looks like this. That's happening. And so our endpoints and our critical numbers are where our maxes will occur. So this is our negative 0.5, this is our 2, and this is our 0. So one of these points will be an absolute max. We already know it's that one. And one of these points will be an absolute min. So now if we go back to our calculator, hit zoom 0 to go back to where we were, we can then plug these in. So what I like to do is I take my negative 0.5, which is my first endpoint. The one that's in the middle is 0, and then 2. So our critical numbers are x equals 0 and 2, and our endpoints are negative 0.5 and 2. Now, these critical numbers have to be within this interval. If they're not, we don't include them. So if I had gotten 3 as a critical number, I would throw it out because I can only use those values. Now, if you've already entered this in the calculator correctly, now all we have to do, and remember this is the original function, is just hit trace, negative 0.5, and it'll spit out our y values. So 3.34375. So how about 3.344? So 3.344. So this is our table to find our values. So this is our endpoints in extrema, and these are the y values they give us. So now if I hit trace 0, comes out to be 3. And if I hit trace 2, it tells me it's 1651. Meaning that this is our minimum value. Why? Because that is the smallest y value. And this would be our maximum because that is the largest value. So our answers for these would be neither, because it's right in the middle of the two. This is our min, and this is our max. So we have an absolute max of 1651 at x equals 2, and a minimum of 3 at x equals 0. And this occurs every single time that we have a continuous function with a closed interval. You start with your endpoints, place any critical numbers that go in the middle here. Whoever is the smallest is your min, whoever is the biggest is your max. And it's that simple thanks to the extreme value theorem.